Hello, in this video I'm going to say a few brief words about Pierre de Fermat, the French, primarily a mathematician. He was also a lawyer, and here he is, he's operating in the 17th century, so born in 1607. So he's a contemporary of Descartes, a little bit before Newton. As I say, he was French. He was born in southern France into a fairly wealthy family, as you'd kind of expect at that time if they were going to be making strides in science and maths. His father was a leather merchant. He studied law at university before he seriously started pursuing maths. He was also fluent in half a dozen languages, so he had quite a well-rounded education. And he's primarily known for number theory and analytic geometry. I mean, he came up with loads of theorems. His early work in particular, he was working through lots of proofs of theories, stuff to do with numbers, algebra equations. You know, he was doing a lot of stuff with, as I say, in number theory. I mean, he's best known, I suppose, for his last theorem, Fermat's last theorem, which well, that's the relationship. If you've got a polynomial, you know, a to the n plus b to the n equals c to the n, then he was saying, well, there's no solution to this. There's no three positive integers a, b, and c for which this equation is true for n is greater than 2. Yeah, we know that it's true if you've got n is 1 or 2. That's just trivially shown. But if n is 3 or greater, then you can't have three positive integers that satisfy this equation. Now, he had this written in one of his manuscripts, and he made a note in the margin next to it saying that he had a proof of it that he just couldn't quite fit in the margin. People now are somewhat skeptical that such a proof actually existed, because it wasn't until 1994 that anyone, and that anyone being Andrew Wiles, who managed to show that this is actually true. You know, he managed to actually prove it. And Wiles was using new mathematics. I mean, part of the process of being able to prove this Fermat's last theorem meant the development of whole new mathematics that Fermat wouldn't have had access to back then. So it seems highly unlikely that he did actually have a proof of this, certainly not one that he could scribble in the margin, or nearly scribble in the margin of a manuscript. So he's particularly known for that. But I've also done a video, which you may have seen, on Fermat principle in optics, you know, the principle of least time. So when we used it actually to derive Snell's law. If you've got some source here and some end point there, and you're going through materials with two different refractive indices, so we're moving faster in the upper material than we are in the lower material, then what path are we actually going to take? And if you minimize the travel time, which is Fermat's principle, then you end up deriving Snell's law off of the back of this. So it's quite a nice exercise in calculus to go through that. So yeah, he did, as I say, a lot of work as well in analytic geometry. So this is just sort of what we now think of really as being Cartesian stuff, but a lot of his work predated Descartes. You know, it contained methods for determining maxima, minima, tangents, things like that were quite similar to now what we'd describe as being differential calculus. And this influenced Newton. You know, Newton was, you know, a generation younger than Fermat, so the following generation that was coming on, and Newton was influenced by Fermat's discoveries. I mean, as is often the way in this particular era, there's the usual problems of priority disputes and things like this. You know, who actually came up with certain things, particularly as a lot of the ideas were shared in personal letters that mathematicians or scientists had written to each other. I mean, it seems that he explored many of the fundamental ideas of calculus before either Newton or Leibniz, but you know, he didn't formulate them as comprehensively as they did. So he was looking into those early ideas. You know, he claimed many proofs of many theories. A lot of them haven't survived. And then you've got as I say, the unlikely sounding ones, such as with the last theorem. He did correspond a lot with Blaise Pascal, and that correspondence is widely seen as being really the foundation of probability theory. I mean, we think of Pascal a lot when it comes to binomial theory and probabilities and binomial expansions and such like. And Fermat was corresponding with him and exchanging a lot of ideas with him in the 17th century. So, yeah, he certainly covered a lot of areas. As I say, he was more of a mathematician than a physicist. But I've included him here for two reasons, really. I mean, how famous he is for Fermat's last theorem, but also this principle of least time that we looked at as we were going through optics. So there you go, a little bit about Pierre de Fermat.